All right, Unit 2 test preview, part 2, getting us ready for our upcoming test. First thing here, we're going to look at an error analysis question. Now, when we're doing error analysis, it's important to remember we're analyzing error, which means that it is not done correctly. Even put it in here for you. She did not do it correctly, so don't say she did everything right, because she didn't. So, we want to rewrite this into vertex form, but she must have done something wrong along the way. So, a couple of things that might help me figure some things out. I have my own help sheet, okay, here on vertex form, if I need a little bit of assistance with something. But it looks like when I look at mine, that Hannah went ahead and did add a value in those two places, sort of like I normally would. So that doesn't seem to be the trouble. Well, let's see. If I didn't see all of this, how would I start it? How should I start any, completing the square problem? Use your cheat sheet on that. The Harty song that you still can't get out of your head, top 10 hit, is take my b, divide it by 2, and square it. That should be the value that's getting added to both sides. Uh-oh. That's not what's getting added to both sides. So, let's do this. Since we've got to do a correction anyway, let's do this right. So I come down here, and I just found out that it's 16 I need to be adding to both sides, not 8. So I follow that same format. I just change up the way that this works. So now, I need to get this into its binomial form. Now remember, I could just factor this. I could use a diamond, kind of what multiplies to 16 adds to 8. That'd be fine. But there's a faster way to do it. And it's just to take my b divided by 2 value and put that in here. But am I quite done yet? No, because I have to be in y equals at the end. So, minus my 16 out of there, because we need it in y equals to be in vertex form. And I get to my answer. So, how did she go wrong? How could she have possibly come up with 8 up here? There's a couple of things I'm thinking about here. One of them could be she just used the b value in the blank instead. B value is 8, she plugged that in. That's one thing, but here more likely, and some of you have done this before, don't say you haven't. Some of you will look at 4 squared, and instead of thinking 4 times 4, you think of 4 times 2. So I think she may have done 4 times 2. Instead of 4 squared. Okay? Those both would be sensible to me if I were looking at an error analysis. But again, that's part of it, and actually doing it correctly is part of it. You can't ignore one or the other. You've got to do all of it. Okay? But again, you've got the help to remind you where the blanks go and what form to get into the end, just in case you were a little confused with that. Okay, for 17, write the circle in standard form, completing the square twice, identify the center and the radius. Again, you have help. Okay? Get the x's together and y's together, constant term to the other side. Okay? And I'm actually going to use colors here because we've done that before. So x's, excuse me, I didn't need to have my parentheses there yet. You're like, Harty, look what you just did. What? It was already set up for you that way. Oh, well, that's okay. So once I've done that, get your calculated b values into the appropriate spots. I'm still doing b divided by 2 and squaring it, and then putting them with the x and y and also with the constant side. So, do my x work over here. Half b square half b add it here. Has the groaning started yet? No. No, that doesn't mean you get to leave now because Harty started trying to sing. Okay. So then I do the same thing with y. Again, my b value. Make sure to take the negative with you in this case and to use parentheses. If I forget either of those, this could get messed up. And then I do that. Whoops, minus. I just talk about sign issues. And add it here. Again, using the colors can be helpful, make things jump a little bit, but using the blanks works too if that's something you want to look at. So then, I've got to go to my square of a binomial again from my perfect square trinomial. So remember, your b divided by 2 value would make that go pretty quickly. Same thing with the y's. My b divided by 2, my negative 3 goes in there. And then 23 plus 4 is 27, plus 9 is 36. And I'm in my standard form for a circle. And again, if you forget, oops, there it is. Parentheses, parentheses, r squared. My center, opposite of h, opposite of k, so the opposite of the numbers you see in the parentheses. And then remember your radius, this is radius squared. So don't write 36, it's the square root of that value. Now, just to make a point here, let's say instead of 36, that had been some number like 30, and you punch it in, you get a decimal. What do? Do you put in the decimal? No. Just leave the radical there. So like if this was 30, square root of 30, A-OK. All right? Right. The bell that's about to ring in a minute, pay no attention. Because we are locked into mathematical wisdom. All right. Area of the rectangle shown, as some of you groan, is 51 square meters. Folks, this is about the easiest formula you could have given to you for this. Okay? Length times width. Not too tough to remember. So when I go to set it up, I go looking for the values that I have. I have the area, 51. I have the length and width, x, and 2x plus 11. Okay, but now what? Okay. I've got to get it set up whenever I'm solving a quadratic. You're like, I don't see any squared yet. Oh, but you will. Okay, we're going to distribute through. And at any time now I can say it, that we see a quadratic, everything needs to go to that side. So the 51 needs to come over. The 51 does not have an x squared. It does not have an x. So I get that in there. And now I have choices. Okay? So basically I'm going to tell you got choices A, B, and C here. So you've got to figure out which way you're going to go. And I'll kind of maybe do them all. We'll see. Factor. I could use the quadratic formula. I could use the calculator and find a 0. Okay? Any of those three will work. And I am going to show you all of them because I want you to have the flexibility to do it any way you want to. So if I go the factoring route, we're probably going to be looking at slide and divide, I'd assume, for a lot of you. So if we're going to go that route, move this guy down. Now, is 102 the most fun number to work with? No. But I do know a couple of things. I know that since they multiply to a negative, since I have a negative product, I'm going to have one of each sign, and I know the positive number is going to be bigger. So my job is going to become, I might try using my multiplication chart if I want to use that, but otherwise, here's what I'm going to start doing. I'm going to start taking 102 and I'm going to start dividing it by numbers. But again, I'm looking for two that are 11 apart. So I'm like, okay, that's not big enough. Oh, that's a decimal. That certainly didn't do me any good. 6. Hey, 6 and 17. They're 11 apart. All right, let's do this. 17 and 6. I know the 17 goes to the plus because that's my bigger number there. But again, remember, this is slide and divide. Remember the other part. If it doesn't go in nice, back to the front. If it does go in nice, that's cool. And then I set each of these sets of parentheses equal to 0. And just a little bit here for time's sake, I will be your super solver. And so I get to here, and you're like, well, wait a minute, I got 2 answers. So how do I figure out what I want to put in the blank? We use a little common sense. And the common sense is, can I have a negative side? No. So if x is 3, and then the dimensions are just literally plugging in the 3 where the x is at. 2 times 3 is 6, plus 11 is 17. So my dimensions would be 3 by 17. Okay, that would be my factoring route. If I went quadratic formula, whatever answer comes out positive when I do the quadratic formula would be my answer. And again, you'll have the quadratic formula literally written right on that part of the test. So if you needed that, you could use it. But let's do the calculator while we're here, because we'll see the quadratic formula again in a little bit. So if I was going to go to the calculator, here's what that's going to look like. I'm going to take my quadratic here. I'm going to do my y equals. And I'm going to type that in. And again, go back to your little sheet that you have, finding zeros, okay? Type in the equation, second trace in 2. Because we want the 0. And once I get that, again, I'm going to move my cursor as close to the x-intercept as possible, and then we're going to go from there. So if you can't see your cursor guy, keep moving to the right, because notice the y value is going to keep getting, there he is, close to 0. And then we're going to go, because again, I'm just following directions. Whoa. 3 left arrow clicks. We're going to hit enter. 1, 2, 3, enter. Then it says 6 to the right. 1, 2, 3, back where I started. 4, 5, 6, enter. And one more enter for good measure. X equals 3. Boom. Okay? So you have multiple options here, but you have to practice to get better at any of them. So pick a way of doing it, practice it, and get after it. Don't want to see a bunch of blanks on this quiz on this one. There's no need. Okay, end of mini lecture. All right. Moving on. If Harty can flip the page. There we go. All right. More applications. Maya. She's shooting an arrow upward. The height of the arrow 2 seconds later is given by this equation. What is the initial velocity? Reminder. Okay. When we're doing these. This is where we start. This is where we end. And this is my initial velocity, not the IV. We are not in the hospital currently. So I don't have to do any calculating even for part A. Initial velocity is just the number in front of t. Good. Now, if we remember the feet per second, great. But if I see the 90, I'm a happy camper. What was the maximum height reached by the arrow in the time at which it is reached? Find the vertex. Okay, the actual height is the y value. The time is the x value. Am I going to tell you this on the test? No. Because we can find it. Once we know that we're looking for the vertex, you don't even need that calculator. What am I doing? Okay, for my vertex, I use my little formula, my negative b over 2a. Well, looky there. It's on my help. Okay? You've got the help there, but you've got to practice it so you know where to find it and where to use it. My b value is 90, so I want the opposite. And then 2 over a. My a is negative 16. So let's punch that in, and let's see what our x value is here. So on negative 90 divided by, use parentheses. Okay, 2 times u. Is that right? Yep. So 2.8125. That's my x value. Okay, that's my time. Would it be the worst thing ever if you rounded a little to like 2.8? No, not the worst thing ever. Okay, so then what? Well, to get the y value, I can either plug these in for both the t's if I'm using a standard scientific calculator, or if I want, I could go back to my calculator, punch the original expression, there it is, punch that in there, and then I would be looking for the y value. So I'm just going to hit trace, and this is on your cheat sheet. Just going to hang on here for a minute. And then I just type in the x value, 2.8125. Boom. So my y value is like 133.56. That's not bad. But again, just make sure you've got your help sheets, your cheat sheets. And then when did the arrow land on the ground? You're 0. Okay, we've done this. I can use the calculator. I can use the quadratic formula. Okay, I'll show you both on this one. So when I get here, if I already got it typed in, which I do, that's nice. So second trace, I'm looking for the 0. Now notice my y number is really big right now, so I'm just going to keep going to the right here until it comes back down to earth. That's about as close as I get, I guess. So I get there, no enters yet. Follow cheat sheet. 1, 2, 3, enter. 1, 2, 3, back where I started. 4, 5, 6, enter, and enter for my guess. Okay, don't, again, freak out if you see e to the something. That just means 0. So 5.7 seconds. So you're like, okay, you said you could do it with the quadratic formula. You're actually going to do it this time. Sure. So my quadratic formula, hey, there it is right there. What a coincidence. So the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And as some of you are writing that down, here's my commercial announcement for my YouTube page and my website. Use them. Okay? You can watch this stuff a few times and kind of see how it works and try it yourself. You've got to take advantage of these things, though, and not just sit there and go, it doesn't work out well. Okay. Since this is an application, I don't care if I get a weird answer. So I'm going to go ahead. I'm going to get out of my graphing function there. And I'm just going to type in all this stuff under the radical. So we'll call that 92.5. And now I've got to use a little common sense. I go, okay, so let's see, negative 90 plus 92.5, enter, divided by negative 32. Does it make any sense that it would hit the ground at negative seconds? No. So I'm hoping the minus one makes more sense. So minus 92.5 divided by negative 32. Check out my answer, negative 5.7 and 5.7. Okay? So either of them will get me to the same answer. Again, you got to have the practice to know that you can use one of them, because I'm not going to tell you which one to use when you get there. So then when we get down to 20, Michael's throwing a rock. Use the quadratic formula to identify when the rock hits the ground. Again, I don't care which way you go with this. Okay? So here, we're going to get two solutions, though. So we got the opposite of b. My b value is 36. Plus or minus the square root of b squared minus 4ac all over 2a. And again, it's an application problem. Okay, the decimal is okay here. So, Harty's going to pop this up here. So I'm getting 47.5 if I round to the nearest tenth here. So now I got two answers working. I got one working where I do the plus and one where I do the minus. So let me come back into the screen here. Now some of you may be wondering at this point, Harty, why are you doing this part and then hitting enter and then doing the divide? Why aren't you just doing it all at once? Because unless I decide I'm going to use parentheses, okay, if I decide I'm going to use the parentheses up top, whoops, I'm fine, okay? Because watch what happens if I don't. Whoa, that's a different answer. Calculator's going to do this division first. Don't you be that person. Okay? We do those first. Period. Now, so here's my two answers. And again, I was just putting that was the positive when I did plus and when I did minus. It doesn't mean this is negative. Are both of these solutions appropriate? So if we took a rock and we threw it out of our tree house, do both of those answers of negative 0.36 seconds and 2.6 seconds make sense? No. Why not? Well, only 2.6 seconds would. Why? No such thing as negative time. Even though, if we stop and think for a minute, unless you have DirecTV, then you have the power to turn back time. Okay, sorry, bad commercial. So, okay, but explain a little bit. Not just, are these solutions appropriate? No. Why? 'Cause. No, just literally think about it for a minute. All right. Solve using the quadratic formula. No applications this time. We're not doing decimals. Okay? You have the quadratic formula sitting right here up above. It'll be the same way on the test. So don't be like, didn't know it. Well, it's right there. So, all right. Opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Okay? This time we go after it a little bit differently. Because again, we don't want to do the decimals. So this time when I do this stuff, I'm not using the radical. Notice there's no radical there. And whatever answer I get, in this case the 41, I just put in there. Now, here's the moment of truth. Does this 41 break down? Is there a perfect square, cheat sheet, that's a factor of 41? And you might try a few, but what you're going to find out is there isn't. So that particular one is done. 22, you're like, why are we having to do two of these? Because I'm trying to trick you on this one. I'll admit it. Well, what do you mean? Before I can start, I have to have this equal 0. If you say your C value is 5 here, you're going to miss this. all of your terms have to be on the x squared side before you start. And once you get here, now you're ready to do all your stuff. Your opposite of b. Your square root of b squared minus 4ac all over 2a. And one more time here, stuff underneath the parentheses, no, let me repeat it again, okay. No radical, just the 56. So negative 6 plus or minus the square root of 56 over 2. But here's where something different happens. When I take out my perfect squares list or think through them, I actually find a perfect square this time that's a factor, 4. And when I take the square root of each of these, one of them breaks down. The 4 does. It becomes 2. So, negative 6 plus or minus 2 square root of 14. There's not a radical on the 2 anymore. Okay, there is in the 14. Over 2. I would be happy if you got here, but just as a point, when I get to here, if there's something that divides into all three of these non-square root numbers, we don't pay attention to this, then I should reduce it, should. So I divide each of those by 2. Okay, but again, I'm perfectly happy with this if I get that. Okay, because I get to the same solution. All right, down the home stretch we come. To the back. Solve the radical equations. Notice it doesn't say by what means. Okay? So you are free back here to use algebra or the calculator, but you remember some of the things that we've talked about. So when I get back here, I'm going to do this first one using algebra, and then we'll kind of go back and forth here a bit. But if you like one way or the other, you can go ahead and try that, because we've talked about some of the caveats of both. So once I get that alone, that radical alone, I'm going to square it to get rid of my radical. Remember, 5 squared, we talked about this at the start of this video. 5 squared is not 10. It's not 5 times 2. It's 5 squared. 5 times 5 is 25. And then I just solve the equation that's left. I add my 3 over, and I divide by 2. Now again, take a moment to make sure that really is an answer before you go on. So I'm just going to do a quick little bit of side work here. 14 times 2 is 28. 28 minus 3 is 25. And you're like, do I have to show all this in the test? No. But again, I'm just making sure that that actually works. And it's always just a good habit, no matter how you're doing these, to go ahead and get your radical alone before you start either way. So I'm going to go ahead and do the plus 5 here. And this one we're going to go calculator on. But again, if you want, you can do it algebraically. So I get here, get my y equals up, type in my square root of x plus 7, and I type in my x plus 5. So remember, on this one now, it's still second trace, except I'm looking for where they intersect. We don't need a fancy, program for that, a fancy cheat sheet. So it'll make my first curve, my blue one there. Make my second line, my red one, and I see they intersect somewhere. And again, I notice that my cursor's on the blue one. That's fine. Anywhere on there's fine. Just hit enter. Second cursor shows up on the red one. Perfect. Okay, just hit enter again. And then one more time for your guess. And the x value should be my solution. Now let's see. So that says x equals negative 3. Double check, look at our chart. As long as the y values are the same, that is a solution. Okay? And I'm good. If you were going to do it using algebra, Okay, just a reminder. And this one I'll kind of, I'm not going to say zip through, but I'm not going to. Remember, you have to FOIL or box this out. If you just put x squared plus 25, you're not in good shape. So Mr. Harty's going to FOIL for you, because I'm a nice guy like that. And then I'd get all my terms over here. I'd do my factoring or my quadratic formula. That would be fine. And I'd set those each equal to 0. Now, here is one of our dilemmas with even doing it algebraically. You're like, oh, well there, whoops, Harty. There's the negative 3 that I got up above. Okay, that's good. Why isn't the negative 6 okay? Reminder, if I try with the negative 6 and I plug it in there, okay, let's do a little check work here. Negative 6 plus 7 minus 5 equals negative 6. Negative 6 plus 7 is 1. Square root of 1 is 1. Is 1 minus 5 equal negative 6? No, it doesn't. Okay? Or, like we said before, with the calculator, let me pull this back up for a second. I could have done that with the calculator too. Because if I'd have gone to negative 6, I'd have seen that the y values aren't the same. Remember, if the y values are the same in the chart, that's a 0. Okay, that's an answer, that's a solution. That gets a set on 24. And then 25, again, always get your radical terms by themselves. Once you do that, you can go to the calculator. That's fine. You just put each of the radicals in on its own line. But in this case, this one's going to work out kind of slick this way. Because again, now both sides, the squareds just cancel with the square roots. I don't have to do anything fancy. I just got to get all my x's together. Minus my 2. Make sure it works. Did I mention that? I mentioned to make sure it works. So 5. 3 times 5 is 15, plus 2 is 17. 5 times 2 is 10, plus 7 is 17. And last I checked, if you take a radical and you subtract the same one, you have a winner. Okay? I can't stress this enough right now. Between the part 1 and part 2 videos, take some time, watch through them, but then see if you can do it on your own. That's how you're going to know if you're ready for this or not, or some things you may need to go back and look at again. Watch this again. Grab an extra copy of the review. Do what you've got to do to be successful on this. I've got the confidence in you. I know you can do it, but you've got to put in the time and effort. Thanks, and good luck.